In this lesson, we're going to examine how to create the equations that are used in factored form. So before we start that, I'm going to come up with a basic idea here that goes back to yesterday's lesson. So we have a parabola, it can be modeled by this equation. I want to know the maximum height reached by this curve. So the fact that the maximum makes me think it's going to do this, which ties together with the fact that it's a negative, which means it opens down. Right? And I want to figure out what is the maximum height, so I kind of want to know what the vertex is. To figure out a vertex, there's a process. We need to know the axis of symmetry, because if I know that, I can get the y that goes with it. To find the axis of symmetry, I need to know my zeros. So I'll always go back to our zeros. The zeros in this case, take them out, change the signs, are -10 and +8. Our axis we know, we can always find by averaging midpoint of our zeros. We get -1. To find our vertex, we know we can always plug our axis into our equation. So y equals -2, -1 plus 10, -1 minus 8. Make sure you plug it into both spots, right? Both x's. And then we calculate our answers. We get -2 times 9 times -9. I'm on the right track, so the brackets match, just different signs. And 2 times 9 times 9 makes 162. This parabola reaches a maximum of 192, and that happens when x is -1. Okay, that's our vertex. So our objective today is to actually take these properties, maybe knowing this kind of thing, and going backwards and figuring out our equation. To do that, we have a little 4-step process, kind of like we did last unit when we talked about y equals mx plus b. Whenever you had to make equations of lines, we always start off by, number 1, filling in what we know. Well, this time, we're always going to know our zeros. So that's step 1, fill them in. Just be careful. Remember to change your signs. When you put things into an equation, you change your signs. When you take them out, you change your signs when you're talking about your zeros. Last unit, once we filled in our slope, like 2x plus b, we needed to know a point in order to solve for b. Well, the same is true for quadratics. We have to substitute a known point for x and y. However, this time, we're actually going to be solving for a, okay, the direction of opening, the size number. And then at the end, you give me your therefore, give me the answer. What is the equation? So let's try the first one together and see if we can make this make sense. So determine the equation if the zeros are are 6 and 8 and the parabola passes through 315. So we want an equation in the form y equals a bracket x minus s, x minus t. We're going to start off by filling in what we know. We know our zeros. Put them in here and put them in here. Just be careful to change your signs. So x minus 6 and x minus 8. In order to solve for a, I need to know a point. Well, I'm given a point. X is 3 and y is 15 is a point. So 15 is y. Don't know a. I need to find a. I need to know how big this thing is, which way it opens. I know that x is 3. Here's what we're going to solve. So 3 minus 6 is -3. 3 minus 8 is -5. All of this stuff is multiplying together. It's all written beside each other in brackets. That means multiplying, right? So let's multiply it. 3 times 5 times a, that makes 15a. I want to solve this, so I can divide both sides by 15, and I get a is 1. Well, that was lucky. It turned out to be a standard size opening up parabola. That will not often be the case. Write down our equation. Y equals a is 1, bracket, x minus s. So we figured out our zeros were -6 and -8. Fill them in. There's the equation for your quadratic. Okay. You can try the next one. Pause it. See if you can figure it out. See if you can get the equation for me. We're going to start off by filling in what we know. X minus 7 and x minus 3. They call them x-intercepts to trick us, but we know those are actually zeros. And we need a point. They're telling me about this y-intercept over here. What do I know about y-intercepts? I know whenever I cross the y-axis, oh, that's a tricky thing. X is always 0. So by telling us the y-intercept of 4, they're telling us it's the point 4, 0. Sorry, 0, 4. So y can be 4 and x is 0. Okay, I need to solve for a. So a, inside the brackets, -7, -3. Multiply it all together, we get 21a. And if I want to divide it out, I've got to divide both sides by 21. Well, 4 doesn't divide by 21 very nicely. So who cares? Leave it that way. Our equation is y equals 4 over 21, x minus 7, x minus 3. There's the equation, factored form. Okay, let's look at the next example. The next example is a word problem. Word problems often seem more complicated than they really are. My suggestion when we're not sure about something is to draw a picture. So what's going on in this situation? We got a golf ball sitting on the ground. Okay, here's my ground, here's my golf ball. It gets hit. It's likely modeled by a quadratic function. Well, common sense says balls go up, ball comes down. Okay, the ball reaches a maximum height of 25 meters and lands after 8 seconds. Figure out the equation. Well, before I figure out the equation, let's turn this into a axes problem. I can draw the axes wherever I want. My suggestion is, why not draw it right there? Because if I do, that makes the ball sitting at the point 0, 0. And because it lands after 8 seconds, that makes this point 8, 0. I'm told it has a maximum height of 25, so up here, that's 25. Well, that's halfway between my zeros, right? The maximum is at the vertex. The axis of symmetry, halfway between 0 and 8, is 4. So I know 4 and 25, and that kind of takes me back to the previous two examples. I got zeros, I got a point, I can figure out an equation. Let's do it. So y equals a bracket x minus my 0, and 1 on the 0. And my other 0 is 8, so I'll put minus 8 in. The point that I know is 25 for y, 4 for x. And we're going to try and solve this. So I have 4 and -4. Multiply that all together, I get -16a. And 25 divided by -16 is -1.5625. It's okay to have decimals this time. It's a nice decimal. It ends, not a never-ending decimal like the previous one. Okay, it's negative, which kind of matches my picture because it opens down. A value negative, makes sense. So my equation is y equals -1.5625 bracket x minus 0 and x minus 8. There's the equation that models the height after a certain amount of time. That's really what these units were, right? This was time. This was height, not necessarily just x and y. So part B of this says, what is the height of the ball after 3 seconds? Well, 3 seconds is time. Time is x. I want to know what happens when x is 3. Let's figure it out. Let's put 3 into our equation. 4x, 1.625, times 3 minus 0, times 3 minus 8 is going to give us -1.5625 times 3 times -5. And if we put that all into our calculator properly, we get 23.4375 meters. Okay, and just common sense says, well, if it reached a maximum of 25 1 second later, yeah, it should be pretty close to 25. Not over 25, definitely not, but I should be getting pretty close to 25 at the very top of this curve. All right, last question. It's a biggie. It's kind of our big idea for this entire unit. Okay. We're looking at a car manufacturer. They sell cars. They make money. Okay. Right now, they sell cars for $33,000 each. At this price, they sell about 20 cars each. If I want to know how much money they're making, I could multiply 33,000 by 20, and I figure out how much money they make. $660,000. But they've done some research. They looked at some previous experience of prior models, and they figured that if they dropped the price, $500, they'd sell an additional 4 cars. So if they were to take this price and bring it down to 32,500, they actually end up selling 4 more cars. And if they do that, they end up with a total value of $780,000. Hey, that's a good deal, right? Every time I drop the price, it goes up. Well, what if I drop it again and again and again and again? Well, eventually, if I keep dropping this price, let's say I dropped it all the way to, I don't know, $20,000. I dropped it a whole bunch of times. Well, that means I'd sell a whole bunch more cars. If we do the calculation, we end up selling 124 cars, which gives us, it's at $242,480,000. Hey, I'm making more money, right? Well, what happens if I drop the price again? Let's drop it down to $10,000. That's a good deal. If I drop it down to $10,000, we'll sell 204 cars now because we've dropped it that many times to sell many more cars. And now we're making, hey, wait a second here. We're only making $2 million now. Oh no, we've dropped it too far. Okay. So the idea of revenue, where you have a price times a number, actually follows a quadratic model. We have an initial value and price, and that combination makes a dot. And then we have another one, and another one, and another one, and another one. And these are going to follow a quadratic model such that there is a optimal price and an optimal number of cars. It's right here. And we want to figure that out. So to figure out a vertex, what do we need? An optimal price needs zeros. If we know zeros, we can get an axis. If we know an axis, we can figure out how many things to sell. Okay, so that's our big idea for this unit. To do this, I'm going to erase all this stuff because it doesn't actually help us solve it yet. To do this, we're going to use this equation. The equation for revenue. The revenue of something involves 2 things. It involves what you're going to charge, your price, and that's what we had a second ago, times how many things we're going to sell. Now we just figured out that if we keep changing our price and changing our number of sales, the price can go up and down, the sales go up and down, it's going to create different revenues. So there's a lot of change involved here. What I don't know is exactly how much change I need to make. So we say X is our number of changes when we deal with revenue questions. And how this equation is going to work is we're going to take our initial value, which in this case was $33,000. That's what each car is being sold for. And we're going to start changing that. We're going to try and find the optimal number of changes. We're changing that by dropping it by $500, so minus drop $500 every time I make a change. I don't know how many changes I need to make though. That's my X. We also knew that we sold 200 cars initially, but that's also going to change every time I change my price. It's going to go up 4 for every change that I make. I want to really point out to you guys here that these 2 things have to be opposite signs. Okay, notice in the equation it's got a plus minus sign. Sometimes we might increase our value, sometimes we might decrease it. But the other plus minus sign should always be the opposite. Okay, you just have to read the question and say, oh, if one goes up, the other goes down. It kind of makes sense. So here's my equation for revenue. Now we said a second ago when I drew the picture that we want to find the maximum revenue, the vertex, if you will. To do that, we needed our axis. To get our axis, we needed our zeros. The weird thing about this kind of question is I can't just look at it, my equation, and write down my zeros because there's 2 numbers inside the brackets. But if we go back to the idea of the definition of a zero, that is the value that makes that bracket equal 0, in other words, 33,000 minus 500x has to equal 0 at some point, we can actually solve for our zeros. We can solve this really simple equation. Put the letters on one side, numbers on the other, divide by 500, and we'll end up with x is 66 for this 0. If we do the same thing for the other bracket, figure out what makes it equal 0, and end up with -5 as my other 0, well, now I've got my two zeros. And why do I want my zeros? I want my zeros so I can find my axis. How do I find my axis? My axis is x equals, add my zeros together and divide by 2. So I get 61 over 2, which is 30.5. What does that represent? This is my number of changes. How many times I need to change my pricing strategy? Okay, why did I want that? I want my axis so I can find my vertex. How do I get my vertex? I plug my axis back into our equation. The equation was 33,000 minus 500 times x. Oh, x is 30.5. My number of cars were 20 plus 4 times x. Okay, and now I'm going to do the math for each of these brackets. I'm going to do them separately, just there's a reason why, just trust me on this. So I'm going to do just the 33,000 part there. If I do the math on that side, I end up with 17,750 times. If I do the bracket over here, we end up with 142. And then if I multiply those two things together, I end up with, here's the big number, 2,520,500. Okay, how do we interpret all this stuff? Okay, we did our zeros to get our axis. We did our axis to get our vertex. Our vertex is our maximum. So we get a maximum revenue of $2,520,500. When does that happen? Well, way back up here in the questions, it says, how many cars and what should our prices be? Well, remember when we made this equation, we had the value of our cars and the number we sold. The value of our cars, the number we sold. Using these two numbers right here, produced our revenue. So how much should we sell them for? Okay, we should sell 142 cars at $17,750 each. Okay, and that comes from my equation. When I made my changes to my prices, it also changed the number of cars. I figured out the optimal pricing strategy. Together, those two things multiplied will make how much revenue you want to make. Okay, this is our very typical question for this unit. We're going to sell all kinds of things. And here we're selling cars, we will sell hot dogs or tickets or all different kinds of things. So we kind of need to know this one. Something I would definitely add to my learning goal sheet is this formula up at the top. Okay, a couple questions to try. There's definitely one of those revenue questions in there. And then come see me if you're having trouble.